Now we are going to start the problem, your 45 problem assignment on 8th unit, waves and oscillations. First problem is from 1990 AIPMT. The composition of two simple harmonic motion of equal periods at right angle to each other and with a phase difference of pi results in the displacement of the particle along. It means it is more than a math question than physics. We know that equation of simple harmonic motion is y is equals to a sine omega t. It is one simple harmonic motion. Other is at right angle, means if one is moving along y-axis, other should move along x-axis. Each and every one knows that x-axis and y-axis are mutually perpendicular lines. One is moving along y-axis, other is moving along x-axis. So there this condition fulfill ki right angle to each other. One more condition is there, with a phase difference of pi, it means omega t plus pi. Their second condition fulfill. Now we want to calculate the locus of the particle where they reached together. It means we have to eliminate omega t. You know that sine 180 plus theta is minus sine theta. So we are getting minus a sine omega t. We want to eliminate omega t, put the value of sine omega t from first equation into second. We are taking its amplitude b, different waves, so we are taking different amplitude. We are taking amplitude of second wave is b. So what we are getting, x is equals to minus b sine omega t I am taking from first equation. It means x and y are related like this, y is equals to minus a upon bx. It means the locus of particle is equals to a straight line like this. So we are going with C. So question was not very tough, but it is a combination of maths and physics problem. Next, it is from 1991. A body is executing simple harmonic motion when its displacements from the mean position are 4 and 5. The corresponding velocities are given. We want to calculate time period. We just finished the theory part. That's why we completed all derivations so that you should strong in basics. What is the equation of velocity? What is the equation of velocity in simple harmonic motion? We saw that velocity was omega under root a square minus y square. What things are given? They are saying when we were at 4 centimeter from mean position, velocity was 10 centimeter per second, means v was 10 when y was 4 centimeter. First relation they gave us. Next, they are saying when you were at distance 5 centimeter, y was 5, velocity was 8 centimeter. Velocity was 8 when y was 5. 5 square means 25. It is equation number 2. We want to calculate time period. You will get time period in omega. Omega is 2 pi by t. So our target is to calculate omega. You can do one thing. First divide one equation by another. You will get on this side 5 by 4. Omega will cancel out. This side you will get a square minus 16 by root a square minus 25. Squaring both sides, we get 25 into a square minus 25 is equals to 16 into a square minus 16. So we will get the value of a, 25a square minus 16a square. We will get 9a square is equals to, take 25 into 25, 625 on that side. 16 into 16, 256. So what we are getting, 15 minus 6, 9. 11 minus 5, 6. 5 minus 2, 4. So what is the value of a square? 9 5s are 45, not a complete number. It means calculation is tough. What they are saying, when its displacement from the mean position are 4 and 5, velocities were 10 centimeter per second and 8 centimeter per second. Not 4, it was velocities were 10 centimeter and 8 centimeter per second. When y was 4, 4 square is 16, 5, it is 25. So we are getting the value of, no problem, we will put this only. A square is 469 by 9. So now we are going to any one equation. Suppose first equation we are moving towards. So 10 is equals to omega under root a square means 469 by 9 minus 16. So from first equation we got this. After taking LCM, this 3 will come out from the square root. What we are getting in square root? 469 minus 16 9s are 144. 10 into 3, 30. 30 is equals to omega into square root of 9 minus 4, 5, 6 minus 4, 2, 3 minus 1, 2. 225, it means 15. So what we are getting? 30 is equals to omega into 15, but omega is 2 pi by t. Cancel 30 with 30, 15 2s are 30, this. So what we are getting, t is equals to pi second. So we are going with option C. So C option was correct. Next, it is from 1992 AIPMT. If a simple harmonic oscillator means SHM has got a displacement of 0.02 meter, acceleration was equal to 0.02 meter per second square. We want to calculate angular frequency. Angular frequency means omega. So target is omega. What is given? When displacement was 0.02, acceleration was, all are in SI units, 0.02 meter per second square. So no need to worry, we have a formula. Acceleration in magnitude wise, A is equals to, acceleration is equals to, we denoted by F, so we will denote by F. F was minus omega square y, but magnitude wise F was omega square y. F is 0.02. omega square. Y is, both are 0.02. So omega square is 1. So omega is also 1. So unit of angular frequency omega, radian per second. So we are going with D option. So in this way, direct problem was there. So what we will do now, we are going to do for this problem, which is from 1992. A simple harmonic oscillator has an amplitude A and time period T. The time required by it to travel from x is equals to A to x is equals to A by 2. It means particle was not at its mean position. Particle is at its one extreme position. We will know when it will reach at extreme position. Means initially P was here. They are taking along x-axis, simple harmonic motion along x-axis. So if P was here, M was at this point. M will reach at this point A when P will move by 90 degree. When P will move by 90 degree. So initially equation was in terms of A, x is equals to A sine omega t. But in this case, motion is starting from x is equals to A. Means already P moved by 90 degree. There is a phase difference of 90 degree. So for this motion, we have to add omega t plus 90 means pi by 2. So for this, x is equals to A cos omega t. Sin 90 plus theta is cos theta. So it means now I am starting my motion from extreme position. So x will get A by 2. When x will get A by 2, suppose in time t. So cancel A with A. So I am getting 1 by 2 is cos omega t. What is the value of 1 by 2? Cos 60 degree. Cos 60 degree means pi by 3. So what I am getting, omega t is equals to pi by 3, but omega is 2 pi by t. So now we can calculate the value of t, small t. What is coming it? Cancel pi with pi. So we are getting t by 6. So we are going with option t by 6. So first I change the equation of simple harmonic motion, because we were not starting from mean position. If you are starting from mean position, you can take equation y or x is equals to A sin omega t. But if you are starting from phi angle, I told you in theory, we have to put equation like this. So from where we started it from extreme position. It means phi was 90 degree. So first I make the equation for this. This is the equation. Then we get the value of t. Next, a particle moving along the x-axis executes simple harmonic motion. Force acting on it is, just we have completed our derivation. The acceleration should be directly proportional to minus omega square x, means minus x. So F should be, acceleration should be equal to minus kx for simple harmonic motion. This type of equation we need. Force is mass into acceleration. So we need this type of equation. So rejecting this, force should be negative. X should not be in power. X should not be a trigonometrical function. So only one option was there. So we are going with A minus AKX. Next, a particle starts with simple harmonic motion from the mean position. Starting from mean position, no tension. We can take our equation y is equals to A sin omega t. its amplitude is A, time period is T, its speed is half that of the maximum speed. What is this displacement? It is displacement equation, but they are talking about speed. What was the formula for speed? V was omega under root a square minus y square. When v will become maximum, when y will become 0, v will be maximum. So, for maximum velocity, y should be equal to 0, because the less value of y will give you more value of v. Square cannot be negative, so its minimum value is 0. So, we are getting maximum value of v omega into a. So, what they are saying, ki at one time its speed is half that of the maximum speed, means velocity was omega into amplitude, they are saying capital A. So, we are writing amplitude capital A, it is capital A. They are saying at one time it was half of maximum value, means it was omega A by 2. Calculate that displacement, no need for this equation. So, we will see, we are going to put this v in this. So, what we are getting? Omega A divided by 2, it was formula from which we got the maximum velocity. So, omega A by 2 is equals to omega root of a square minus y square. Cancel omega with omega. By squaring both sides, what we are getting? A square by 4 is equals to a square minus y square. So, what is y square? A square minus a square by 4 means 3a square by 4. So, what we are getting? Plus minus means on both sides you will get this. So, but all options are positive. So, I am taking only positive option, root 3a by 2. So, I am going with A option. Next, two simple harmonic motions with same amplitude, same time period acting together in perpendicular directions with a phase difference of pi by 2 give rise to, again, problem of a locus. If I am taking one equation, y is equals to a sin omega t, same amplitude acting together in perpendicular directions. So, for other simple harmonic motion, x should be a sin omega t plus pi by 2. What you will get? A cos omega t. What is the locus of that particle? Remove omega t. So, from first equation I am getting sin omega t, y by a. From second equation I am getting cos omega t, x by a. We know that for any angle sin square theta plus cos square theta is 1, means y square by a square plus x square by a square is equals to 1, means x square plus y square is equals to a square, which is the equation of a circle having center at 0, 0 and radius a. So, we are going with circular motion. It was a problem from 1997 AIPMT. Remember that if A and B are not equal, then you will get the equation of ellipse. Next, again same type of problem. The equation of two waves acting in the perpendicular directions are given as x is equals to a cos omega t plus delta, y is equals to a cos omega t plus alpha, and delta is equals to, I think it is should be misprint, it should be alpha plus pi by 2, because all are angles So theta square cannot be equal to theta. Dimensionally we are talking about like that. So delta is equals to alpha plus pi by 2. The resultant wave represents, again same type of problem is this, x is equals to a cos omega t. What is delta? Delta is alpha plus pi by 2. Y is a cos omega t plus alpha. So x should be a cos pi by 2, I am writing in this way now, plus omega t plus alpha. See, cos 90 plus theta is minus sin theta. So what we are getting? X is equals to minus a sin omega t plus alpha. And what is y? A cos omega t plus alpha. So again same type of problem is this. So from this equation I am getting sin omega t plus alpha, which is minus x by a. From this equation I am getting cos omega t plus alpha, which is x by a. By squaring and adding we get sin square omega t plus alpha plus cos square omega t plus alpha is equals to, it is y. It is from cos I am getting y. It is y. Y upon a. I am getting x square by a square plus y square by a square. It is again 1. So I am getting x square plus y square by a square is equals to 1. So again we are getting the equation of a circle with center 0 0, radius a. So we are going with B. It was from 2000 AIPMT. Ninth problem. A particle executing simple harmonic motion of amplitude 5 centimeter has maximum speed of 31.4 centimeter per second. The frequency of the oscillation is, again we know that just we saw it is a problem from 2004 AIPMT. We know that maximum velocity of particle in a simple harmonic motion is omega into a. What they are saying, V maximum is 31.4. We are doing in CGS system. Omega is, because in CGS SI both system frequency unit is hertz only, because it is reciprocal of time and time has same unit in all systems. So 2 pi by t into amplitude. What is amplitude? 5 centimeter. Amplitude is 5 centimeter. So what we are getting? 1 upon t is frequency. So keep this 1 upon t on this side. On another side 31.4 is there. Take 2 pi and 5 in denominator. And 1 upon t is frequency. Value of pi, you know that 3.14. So 2 into 3.14 into 5. It means 31.4 upon 31.4. 5 into 2, 10. 10 will shift the decimal and we will get 31.4. Cancel this with this. So what we are getting? 1 hertz. So we are going with option D. Next, it is again from 2004 AIPMT. Which one of the following statement is true for the speed v and acceleration a of a particle executing simple harmonic motion? velocity's formula is omega under root a square minus y square, and magnitude of acceleration is omega square into y. When y is maximum, v is minimum, f is maximum. They are saying acceleration a, so we will write acceleration by a, and this amplitude we can write capital A. Amplitude we can write capital A, and acceleration we can write small a. It is given in question, that's why. So when v is maximum, a is maximum? No. Value of a is 0, whatever may be the value of v? No. V will 0 according as y, and a is also dependent on y, so y will decide, so we are not going with b. When v is 0, a is 0, again wrong. Both are not maximum or minimum at same point. When v is maximum when y is 0, a is 0, it is correct. So we are going with option D.